we have one null. It's got to fit all three of these cases. Okay, we didn't implement more than one null. So nulls can cause their own problems. This is the famous, you know, the reason I remember this kind of thing is that I used to do repair construction equipment, and we had like jackhammers was my specialty. So we had like a little chart of what to do, and there's like a joke chart, and they had like a nut that was knurled, you know, has like little lines on it, and it said, it had a picture of the nut. It said knurled for vice grip torquing, you know. So they knurled it just so the vice grip could get what, you know, is really what you don't want to do. So this is the kind of thing, don't do that, even though it looks like that's exactly what it's supposed to do. That's not actually why they have the little lines on the bolt. So again, you have to be very careful in those. Only use them in situations where you consider appropriate. In fact, I would argue that the not null specification for columns should be used much more aggressively than they do. In fact, I have another talk where I basically say that the common pattern that people use when they define a table, right? Create table name. And what do you think? And I'm from the 90s when we used to have regular databases that weren't as sophisticated. And I don't think people can hear me any now on my thing. But anyway, so when you say column name and then data type, your natural inclination is to do what? Comma. Am I right? Column name, data type, comma, column name, data type, comma. And what you're losing is a whole expressive language of constraints, not null, check constraints, primary keys, a whole language that allows you to more accurately lock down your data and prevent those weekends where we have to figure out why our report doesn't balance anymore. Those can be eliminated if at creation time, every time you create a column, you're thinking, do I want nulls in this column? Do I want a check constraint in this column? Is this column unique? Is this column a primary key? You know, there's a whole bunch of constraints that Postgres and most relational systems support that a lot of times don't get added to databases until after you've had a couple of those weekends where the system doesn't match and you can't figure out why, and then you have to figure out how the data got in there, and you could have prevented it all along. Okay, so this is not new. I'd love to say I am like the person who's figured this all out, but it's totally not true. The only reason I wrote this slide deck is because we have hit this so many times with Postgres users. We have had so many, it's so confusing. But in fact, the confusion dates back to when, yeah, the little joke dates back. You get that? Huh? Yeah, CJ date up there. Dates back to, these couple of people are still not sure what I said. CJ Date was the father SQL, and Joe Selko here is critiquing his design for nulls. And in fact, you know, right at the top, and Joe Selko has spoken at Postgres conferences. I think he's spoken at 2 of them, actually. One in Prague, and I think he's going to speak this year in Ottawa, or this year I think he's speaking in Ottawa. Anyway, he gets around. He's very friendly to Postgres. But he says about nulls back in his book, SQL for Smarties, Advanced SQL Programming. It is this writer's opinion that nulls, at least as currently defined and implemented in SQL, are far more trouble than they are worth. You gotta love that. And should be avoided. They display very strange and inconsistent behavior and can be a rich source of error. Right? Just to highlight that, rich source of error and confusion, yes. Please note that these comments and criticisms apply to any system that supports SQL style null, not just SQL Server specifically. I guess he was talking about something. In the rest of the book, this is sort of the sausage part. In the rest of the book, I will be urging you not to use them, which may, I'm sorry, in the rest of the book, I will be urging you to use them, which may seem contradictory, but it is not. Think of a null as a drug. Use it properly and it works for you, but abuse it and it can ruin everything. Your best policy is to avoid nulls when you can and use them properly when you have to. Great wisdom there. Again, out of his book, I think it just says a lot. And it sort of says this is not virgin territory here. This is territory that unfortunately we've all, these sort of pillars of relational history have also been in our shoes. There's a lot of text here in this slides. So you're going to see a lot of queries. When you see a query, keep your eye on the red, because that's the part that I'm highlighting for you, is the red part of the query. And the rest of the part is just there for kind of window dressing. Let's start with a very simple case here, explicit nulls. So and again, this is all going to be Postgres based. And again, keep your eye on the red text. Actually, let me ask, does anybody have any questions so far? Because again, I want to take questions while I go. Okay. People are too entertained. Okay. So select null. That's an explicit null that I'm asking for. I'm saying, give me a null, and you get an astounding nothing. It's just blank. This actually gets into one of the problems I believe that Oracle has, where they consider zero-length strings to be nulls. It's really ugly. They look the same, so why can't we treat them the same? There's that logic to that. Postgres does not do that. We're actually very finicky about that. Almost any place where we're going to place a null, it will always distinguish from a zero-length string. For example, the copy output would use \N for a null versus a zero-length string. Yes, sir. So that is a great question. So isn't a zero-length string null terminated? It is. It is. And that gets back to that slide where I actually complained that C kind of has this nulls going multiple directions at the same time. So there is sort of a logic to saying that, but it leads to a lot of confusion in relational design when you have that happening. There was one system, I think I worked with Informix, when they dumped a null out, they dumped it out as a zero-length string. So when you import a zero-length string, it became a null. But when you output a zero-length string, it came as a single space. So null went out as a zero-length string. A zero-length string came out as a single space. So that works, like when you bring it out and back in again. But a single space also came out as a single space. And then it went back in as a zero-length string, okay? So because I remember looking, this is when in the late 90s, I was working on Postgres. We got it from Berkeley. We're looking at the design, and we're like looking at how the nulls are handled. And I'm like, this doesn't look right. Like I had dealt enough with Informix to know that when a database doesn't load, dumps out data and loads it in differently than it went in, that will bite somebody. Don't even go there, right? And when I tested Postgres, there was these really weird edge cases where we didn't do it. And in fact, I think it was like 97, very early, when I basically implemented the \N for null. So you always got this unique string out, and a backslash would be, a literal backslash would be double backslash, so that we already had a backslash. But Informix didn't have that backslash escape mechanism. So like if you had a new line in your data, well, it wouldn't load in anymore because it thought the line was done, but it wasn't done, right? So Postgres, when it has a new line, it does \n, so it knows it's not a real new line for the copy. It's actually like part of the data. So I would have loved not to have to implement like special handling for nulls, but you had to, because you had to make sure you gave something unique that never could appear as data, because someone will have data. Someone will have that single space that will not load in the same, and it will do something horrific, so you just don't want to do that. One interesting thing that you can do in PSQL is you can actually ask the system to give you a null with a special like flag, so a special string. So instead of writing this and getting nothing out, you get actually the string. So here I'm actually using, say, pset null and using this special string, and again I get the special string out, right? So that that works really good. And I'm going to actually use that special string most of the slides. So kind of like when you see a null, it's going to come out literally just so we can see it, because again, it's got that ephemeral. And I'm sure there's some Homeric allusion to this, or there's a whole bunch of stuff with when they strap him to the mast and he goes by the the island with the women, and he's got the monster who's called Nobody or something. It's the same kind of double meaning kind of confusion here that has existed forever. So let's take a look at explicit null assignment. This is where we're actually putting a null in the database for some reason that we actually hope is the right reason. So we're here saying insert into here, null test. We create a table, 2 columns, 1, and then the null value, and literally the null value comes out. And again, I've specially flagged it. It wouldn't normally come out as nothing, but we've specially flagged it here to say, no, there's nothing there. Okay. Another case, and this is an explicit null assignment. This is an implicit null assignment. This is where it starts to get a little interesting. Now, you don't see a null anywhere in this line here, right? Remember I said earlier that number 3, the third case of nulls, is cases where the SQL requires a null. You don't explicitly put it in, it just shows up. And this is a case where it shows up. The reason it shows up is because I have 2 columns in this table, but I'm only supplying one of them. And because the row has to have both columns, because again, it's a relational system, every row has the same number of columns, I did not give a value to y. So I have to put something there as an SQL, as an internals person, I have to put something in that row. I could put 0. Now that's actually would work because it's an integer. I could probably put 0. But what would I put for a string? Oh, well, I put a 0 length string. What should I put for a date? Well, I don't know, right? So you start to see that if I tried to put special values in here, it might work for some data types, not others. You get this weird kind of case. And if you think of some of the non-relational systems out there, like Paradox and some of the older ones, like they always did like weird things with when you missed it. Some of them had special values and some of them didn't. So relational systems got rid of that and just said, if the value is not supplied, it's a null. Okay, so that's a great case of a null being generated dynamically without me specifying it. It had to put something there. It logically put a null. It will put a null for every data type, no matter what that is. Okay. So what we can do, and we talked about this already, is the idea of restricting columns to not have nulls in them. Okay, and there's some value to this because all of a sudden, if I have like customer name, I really don't want to have a record with a null customer name. I'm not going to go there because you can imagine how you track that back. Like, what customer is it? Oh, you have to guess. There's nothing there, right? So what I've done here is I've actually used the constraints and I've said here, my table name, and I'm going to say not null for this column and not null for this column. And now if I try and explicitly put a null in, I get an error because of a violation. And if I try and implicitly put a null in there, I get an error. Okay, this is a great example of us kind of blocking out where we want nulls and where we don't. I would love to have a mode where you have to say, I want nulls in a column. I mean, wouldn't that be nice? So everything would default to not null. But that's not the way SQL standard is. There's no mode for that. Yes. So the question is, if you wanted to explicitly say nulls are allowed, you could put the word null after the field, after the data type, to say, I do allow nulls here. But because the default is null, nobody uses it because it doesn't have any meaning, right? Yeah, so that I would love to have had the standard the other way. The reason it's not that way, I think, is because there's probably some pretty complex reasons why, because if you disallowed nulls, there'd be a whole bunch of query types that would be kind of have weird behaviors, particularly like an outer join. So, you know, I can see why they didn't do that. Yes, sir. So not null should be a default when defining a table, but you allow the output from a column in an outer join to be null. Yeah, that would kind of work, but the problem, yeah, that would work. Yeah, because you're right. Even if you put not null, you can still do a join, it would still come out. So you're right. I think there's an argument to say that we should allow nulls. We should require people to explicitly say which columns they want to have nulls. And unfortunately, that's not the way the language works. So we have to write a lot of not null, or we just do what I did and just hit the comma and move on. And I think in some ways, how do I, maybe I don't want to be too harsh, but in some ways, when we're creating a table that we're going to use for years, we kind of create it in like 2 minutes to some extent, okay? Because we're looking at it and we're like, oh, I need that table. Let me just go create it and start putting data in it. And then like a year later, you're like, well, maybe that column name wasn't the best. Or maybe I should have put a not null in there, or maybe I should have done a different data type where I had some check constraints. And you can go back and change it. Postgres allows you to do a lot of that. You can rename columns and change data types and add check constraints to it. But it's ideally it's done at the beginning, so your application doesn't have to be retested. So again, maybe a little caution there to be a little more careful at the front end versus the back end. And in fact, Richard and I were talking about not only the creation of tables, but the selection of databases sometimes happens at the front end, where you're looking at a very well-defined API of what you want a database to do. But the reality is that 2 years later, what you're going to need that database to do is completely different. And if you've locked yourself into a certain database, even if it isn't relational, you're kind of stuck there. And it's very hard to kind of migrate out. It's very hard to know the future, of course, but lack of flexibility in choice of table and lack of flexibility in terms of database product is a concern. So here's where it gets a little kind of creepy. We start to get a little head to the side, kind of look what is going on here. Here's an example where we're actually doing some manipulation with nulls. And this is where we start to get sort of what we call the three value logic of SQL, which I'll talk about in a minute, but I'm just going to highlight right here. So if you take a null and you add a number to it, you get a null, because unknown plus 1 is unknown. Kind of makes sense, okay? Unknown, and you concatenate a letter to the end of it is unknown. If you take a letter and you concatenate null to the end of it, it's still unknown. It kind of works. So null is actually this unknown value. That's where they call the three types of logic here. So here we're going to actually create a table. We're going to insert a null as one of the 3 rows. So we have 31, 41, and null. Okay. The curve is this. The curve's going to. This presentation is going to be a little sharper here as I go up. So here's we're going to actually process this. So here's where you start to get that 3 value thing. Does a null equal 1? Well, does unknown equal 1? I don't know. That makes sense. Does unknown equal a 0-length string? I don't know. Does an unknown equal another unknown? Well, they could be different unknowns, right? So they don't. It's null. This one kills me. Is a null less than a null plus 1? I don't know, right? This can get you, because when you think logically, you're like, well, I don't care what the number is. If I add 1 to it, it's going to be bigger. I don't really. There's not a whole lot of variability there. But in fact, the SQL standard does not allow us to make like heuristic understanding of these things. So therefore, we just have to return unknown. Okay. So null represents an unknown, not applicable or not assigned. It has no data type, so comparing it to fixed values always return to the null. So just to kind of put that in the back of your head. So we can actually do comparisons here. So the null actually operates as though it were false, although it isn't false. So if I say select 1 where true, that's going to be 1. Select 1 where false, that's going to be nothing, which we expect. Select 1 where null, that's also nothing. So even though in a where clause, the unknown has the effect of a null, because the where clause only returns true rows. Only returns true rows. Then you think, well, that means it just doesn't return false rows. No, because we have 3 values of logic, right? It returns true rows, but it doesn't return false rows, and it doesn't return unknown rows. tell me how crazy it would be if we allowed where to return unknown rows. That would be like, I think our whole database systems would blow up. But you're going to start to see where that actually becomes interesting in a minute. So let's start to actually work with the sort of the logic here. So a null is not false, and you got to kind of get that out of your head, because if I say true and null, that would kind of make sense, because true and false would be null. In fact, it doesn't even return false. It returns I don't know. Okay, and not null also returns I don't know. So if null was false, then not false would be true. But in fact, because null isn't false, this sounds like a stand-up routine. Because not isn't false, then it just turns I don't know again. Yes, sir. So have I done this with MySQL and any chance? I would hope that MySQL returns the exact same results. There's going to be some crazy stuff toward the end where I'd use some Postgres specific stuff, but I would be surprised if anybody does anything different than what I'm showing, but I've never run it myself. However, I believe I have, I thought I had a script that allowed you to run this on your own, but I guess I don't have it. I thought I had written it up, but maybe. Yes, sir. Yes. Yeah. Okay. So Richard Hipp was saying that he did some research on this, nulls handling across all the databases. The only difference he found was that in a So he's saying that in Informix and Sybase, right? No, Informix and SQL Server, they would treat nulls as distinct and unique indexes on a unique column. They do not. Now, when you say return them, what do you mean by distinct? Because Postgres will allow multiple nulls in a unique column. So that's really what we're talking about. Oh, right, okay, so Informix and SQL Server, if you create a unique index, you will get one null in that column. And once you put that in there, you're done in terms of adding more nulls. And the SQL standard can go either way. That's very interesting. I wasn't even going to cover that, but that's a great analysis. We've had people ask about that behavior. And we've always been like, yeah, we like the fact you can put multiple nulls in unique index. We kind of like that because they're unknown, so you can have more than one because you don't really know if they're conflicting or not. I think that's the logic behind it. Null operator comparisons. This is again kind of interesting. Remember, we have our original table here: 30, 40, and null. If I say give me, this is where people get bitten a lot, where people are starting to think logically. Don't do that. So here, for example, I say, give me everything greater than 0. That's pretty clear. That's going to be 30 and 40. We don't know this value, so we're not going to return it. That makes sense. Give me everything less than 0. So this is greater than or equal to 0. This is less than 0. This is where a lot of reports get lost. This is where a lot of misbalanced reports, financial reports, I can speak from experience, where when you're writing a report and you're saying, okay, this is my bucket that's all greater than or equal to 0, and here's my bucket that's all less than 0, and they should add up to the total. And when they don't, you're like, why don't they? That's when that weekend overtime comes in. Or usually for me, it was Friday nights in the law firm with one of the staff trying to figure out why we can't close the month because we can't figure out why we're not balancing. Because we're heuristically trying to figure out where all the numbers are, and you're talking about millions of transactions, and don't do this. The last one I think is a classic. Give me everything less than 0 or greater than or equal to 0, right? Pretty clear. You would think that would get your whole shebang here. It does not. So just don't be careful of thinking any type of range operation that you've got everything if you've covered the range, because you've got to also cover those nulls. Null and not equals. This is, I think, kind of a classic. Give me everything that isn't 10. Well, 30 isn't 10, 40. No, we don't know if it's not 10, so we're just not going to tell you about it. And again, the same type of, like, give me everything that isn't 10 and everything that is 10. Again, it's completely, AWOL there. Because again, we're not going to heuristically go through the where clause and say, well, by definition, an unknown would have to fall into one of those two buckets. We just don't do that. We're not, the spec does not, I think, allow us to do that even. Little more interesting. This gets a lot of people. Nulls and not in, and this is just an illustration. So 1 is not equal to 2, and 1 is not equal to 3. That's true. Okay. 1 is not equal to 2, and 1 is not equal to 3, and 1 is not equal to null. It's not it's not true. It's not false. It's null. We don't know. Okay. That when you see that, that looks pretty easy to understand. However, let me flip it over here. Let me say, is A in this null output? And in fact, I don't know. Is A not in this null output? And that's also I don't know. Okay, because I don't know if it's in that, if it's that thing or not. And then we get a little more creative. Is A in here? This one actually works. So is A in A or a null? Well, we know it's here. We don't really care about this rest of the part. We're going to say true. Okay. This is where it gets going. Is A not in an A, or is it not in a null? And that returns false, because you know A is actually in A. So that works. So I know I can short circuit that one. Is A not in B or null? That one I don't know. I'm sorry. Is A in B or here? I don't know. And is A not in B or null? I don't know. And this, again, this is a very, very common case where you're doing a not in subquery. That not in subquery returns some null values, and all of a sudden you get wacky returns because it doesn't know what happened. Because all of a sudden what happens is that every comparison for that row that goes into that subquery returns null out, and then you've got nulls kind of parading around in your where clause or not returning anything. And you're like, well, where is it? I can't find it. It's because you had a null in there, and all of a sudden all your comparisons are returning false. So the whole thing just fell out. It's not a question of which values you compare. It doesn't matter what value you compare. And for some reason, in people can get like, okay, I got to know. The not in really throws them off. So as soon as that subquery returns a null, every comparison going in is going to return an I don't know, a null, which is going to effectively be a false. And then you've got to debug your query. So a lot of these subqueries are going to need like a not null test in the where clause to prevent those nulls from percolating up into your query. Any questions? Okay. Expanded the query out a little bit. This is basically what it's doing. So you're saying, is A equal to B or is A equal to null? That's I don't know. The not in, is A not equal to B or is A not equal to null? Again, I don't know. Kind of weird, but that's effectively not in subqueries return nulls are often problematic. Understatement. Explicit null comparisons gets interesting. Is a null equal to a null? Yes. In fact, I don't know. When you need to compare to a null, there is a special clause called is null and is not null. These are designed not to do equality comparisons, but actually to do null comparisons. And this is the type of clause you're going to start to need in your subqueries if you think your subqueries are going to have nulls in them. So I say, is null is null? Yes, it is null. This is basically where I kind of pull null out of that unknown category, and I now map it into a true false zone that I can more easily understand effectively. Okay. More comparisons here with the not is null. So here I can now break apart my queries. I can now kind of separate them. I'm going to say, give me all the rows where it is null. Give me all the rows where it is not null. And this is, again, if you're thinking of breaking it up, remember greater than 10, less than 10, greater than equal to 10, less than 0, whatever. You're probably also going to need an is null test in there for that third level of logic. So even if you had, greater than 10 and less than equal to 10, you still need a third one to say what to do if it's a null. And that is null test is usually what you're going to use. Comparing nulls with true false logic. This is a weird function that I actually have trouble kind of getting my head around. It is an SQL standard clause. It's a way of kind of mapping nulls to true and false in a comparison of a number. Is null and is not null is just saying, is it a null, is it not a null, right? Just pretty clear. But distinct from is the full name of the clause. So I say is 2 distinct from 1. Well, yeah, it's distinct, it's different. Okay. Is null distinct from 1? I can't really give you a good reason to explain this, but effectively it's true, which means it's basically allowing you to, instead of mapping null and everything else, distinct is basically saying, is it this constant or is it null or any other constant in the world, right? So what I'm saying is null distinct from 1. The only case I'm going to get a false here is if this is a 1. And if it's anything else, if it's 2, 5, null, doesn't matter, I'm going to get a true. But the problem I have is the distinct from is effectively reversed from the logic I would normally think of. So when I really think of it, it's not distinct from is really the where I normally would use it. Is null not distinct from like 1, and then it would say true or false. It's a really awkward. I would really like they had done it better, but in fact, here you even compare a null to a null. Is this distinct from that? And it says false. Is null not equal to 1? Well, that's going to return null because that's so. Again, it's kind of taking that nullness and kind of stripping it away for us for comparison to constants. As I said, the one I really prefer is not distinct from. So give me all the rows where X is not distinct from 30, which effectively is the 30 row. Give me all the rows where X is distinct from 30. That's where you start to split it apart. I have now my row of 30, and I have my row, and it doesn't have to be a constant, it could be anything. But effectively now I'm doing, I've got my 30 and I've got my 40 and my null kind of grouped together. So again, that distinct from allows me to take a constant, put everything in one bucket, and then the not distinct is effectively everything that isn't that constant, including the nulls. I find it very awkward personally. Comparing nulls to other nulls, this gets kind of interesting. So if I actually have a table with 1, 1, 2, 3, and null, null, and I say select star from distinct where X is not distinct from Y, because remember it's 2 columns, I actually say that is not distinct from is saying they're the same. Again, I wish they just said it's the same or something better. I think they use the distinct from the select clause and they just reuse the keyword. Like, why would we use another keyword? And that's why they did, I assume. Yeah, you consider yourself lucky. It is. I see. So if X is Y, okay. That's interesting. Does the standard allow this to be optional? I have a, okay. Because I just don't like it because they reuse the, hey, say select distinct. So they just reused it. Yeah, distinct from just like is, yeah. Right. Well, it's actually, you're already saying is null, right? So but the problem you might get into, and I haven't thought about this, is this case. So when you say null is null, right? See, the problem is that you have is null from way back here, okay? And now you have is null. I think you need to test a little bit to see what that does. So that's what that distinct thing does. It's very useful for joins, actually. And I know it sounds kind of weird, but when you're saying, if you want to join two columns and you want the nulls to kind of go together, you can say column is not distinct from some other column, and those are going to return true, even if they're both nulls. Or if there's, you know what I'm saying? That's where you kind of, it starts to get useful. Can't say I've completely wrapped my head around it, but that's when we use it usually, is in a join that might have null joins in it. This kind of gets, we start to kind of go a little off the rails here. Ordering of nulls. Well, these nulls are unknown and we don't know anything about them, but voila, we now know something about it because we got to order. So all of a sudden we have a practical requirement that we've got to order these things that we don't know about. So we can't just randomly throw them somewhere in the output. And in fact, in this query here with a common table expression, which Richard will be covering tomorrow in his talk, we actually have a select that has a null, a 2, a 1, and a null in it. And then we order by that column, and voila, the nulls are treated equal for ordering purposes. So even though they weren't equal before, all of a sudden we can now put them at the bottom or at the top. You can actually control nulls first and last. You can control where they go. Okay. In fact, here's the example: order by 1 nulls first, and all of a sudden they percolate up to the top. So we can actually do comparisons with nulls. Who knew? Because effectively we have to do comparisons when we're talking about ordering because we don't have a choice. So practicality rules here, and we actually can compare nulls. Unique indexes treat null as unequal. This is, again, what Richard was talking about with the unique index. You can create a unique index. You can put multiple nulls in there. We're certainly happy to do that. Informix and Microsoft SQL Server are not. Nulls and aggregates. This is really a little bit of a head bender here. And I'm going to walk through some of them. There's one or two that make no sense, but it's kind of like the same case where you're like, well, I got to give the user some kind of number here. Help me. And that's kind of what the standard requires here. So I've created a little table called ag test, and I've inserted into ag test some values 7, 8, and null. And aggregates are, earlier on it said nulls are a rich source of confusion. Aggregates are really that on steroids, I think. Any aggregate that gets a null in there is going to have some really unusual behavior, and you should start to think about like how you're going to behave there. There is some argument to say you shouldn't let nulls get into your aggregates, but again, SQL has a definition for it. Just make sure you understand it. So here we have a select of count, and you can see that we actually have two counts here. One is a count star, and the other one is a count on the X column. And we also do a sum, a min, and a max, and then an average. Okay, so we're just kind of taking these 3 rows, one of which is null. We're throwing them into an aggregate. What do we get out? Count star. We have 3 rows. Yay, 3 rows. I get it. We put 3 rows in. Count of X is 2. 2, 2, 2. Why? Because we have specified a column here instead of a star, and count by definition will skip counting null rows with null values in that column. Okay, so count star and a count on the column are not the same. Count on the column will skip the null values in that column. Okay, sum. Okay, well, we got a 7 and 8 and null. Well, back earlier when I had a 7 and 8 and a null, what did I get? Null. Well, why do I have 15 here? Well, this is called expediency, folks. They just figured, well, if we just give people nulls all the time, they're not going to find the function very useful. So we're just going to skip it. And we kind of skipped it over here. So if we kind of have the logic that we're skipping counting values that have X, then there's some logic to say we can skip them in sums as well. Okay. If you kind of, again, this is where the head starts to get a little sideways. So there, the sum is 15. The min is 7. No mention of the null at all. The max is 8. And the average is 7.5. We'll just ignore the null there. Just pretend it doesn't exist. Then it gets a little more interesting. We delete all of the rows from the table, and we run it again. So on an empty table, this is kind of select count star from an empty table is 0. Count on the column X is 0, but the sum is null, and the max in the null, and the average is null. So why is this? I don't know. I have really trouble figuring that out. Why these aren't 0? Yeah, I really, this is just basically a practical problem of what to do with all these cases. So yeah, sum of 0 rows is null. So, okay, I don't know why it's not 0, but I can imagine why a min and max would be null, because like, what do you return? Like for a string, what's a max string? Like, I don't know. It's just, I don't know what you'd put. So I think they just kind of punted on this one. And they said, you know, we got some, we could probably return 0 there, but then the min and max and average are going to be really a problem. Now, average would probably be just 0, but min and max are going to be a problem. So let's just null across the whole board there, and just ignore it. And that's actually what they do. So then we're going to insert again, and we're going to put 2 nulls in this time. This gets a little more exciting. You can see all the edge of your seats. So we have 2 nulls, which you've inserted, and then we do the same query again. But in this case, we actually do a group by and an order by. And what do you know? The system has no trouble comparing those 2 nulls as being equal, which again we proved earlier that it didn't do. In fact, it tells us we have 2. This is kind of interesting. We have 2 rows in the table, but the count on the column is actually 0, even though we're showing that we actually do have some nulls in there. Okay. And then we have none of the other stuff they're all null. So again, standard committee, they figured, well, you know, I think it would have made some logic just not to show that line at all, but for some reason, group by gets a religion, and they figure out we're now going to group all these nulls together. Now they're all equal, and we're going to count them, and we're going to give you a row. So again, trying to have an aggregate and thinking, oh, an aggregate is just going to sum them up as though I was doing it in SQL is not actually true. These aggregates are not behaving the exact same way they would if I just ran the SQL to do the count or the average. Okay. So again, just expect there's a little, and this is again defined by the SQL standard. Mapping nulls to strings. I'm sorry, this is a little smaller in type than I wanted, but I wanted to get it all in the string. There is a function called coalesce. I have trouble saying it, but it actually is a function. And what it's designed to do is to map a null to some constant, usually in this case. So it's kind of like a big case statement, except they've kind of whittled it down. So we normally say case, if null, is null, do X, is not null, then do something else. So here they're basically saying, give me this value, but if it's null, give me this value. That's all it really does. And I think Oracle has some weird decode thing, which is even more crazy than this. So I'm not even going to go into it. But say coalesce, if this is null, then return this value. So in fact, if I say coalesce null of 0, it gets 0. Coalesce of null, I am null, I get I am null. Okay. Now let's run it on a table. We're going to insert F, G, and null in here. We're going to say, give me the field and give me the coalesce of X, or if that's null, give me n/A. This is where it starts to work with reports. Because again, showing a blank really doesn't help you when you're running a report. This allows me to map the null into some type of display that I want to come out. So here we're saying F and a G, and this row, which is null, is actually giving me a nice NA here for the coalesce column. So I'm feeling pretty good. Concatenation. I remember I showed you before when you concatenate 2 things together with a null, you get nothing. That was at the beginning. But here, if I say A and I would concatenate it with some value, and if that value is null, give me a 0-length string, we're good. Okay. So anytime you're doing concatenation, if any of those fields or values might be null, you probably want to throw a coalesce in there. I am not sure all relational systems handle this that way. I have a memory, and David, you will help me, that MySQL will allow you to concatenate a null. Is that right? It will treat as a zero-length string. Yeah. So in MySQL, that will treat as a zero-length string. In Postgres, and I think the SQL standard relational systems, you'll actually need to put coalesce in there. So here I'm saying a column or a value, and B, here I'm actually saying I want a zero-length string there, and in fact, I get AB like just like that. Do you remember I said a sum of a null is a null? Remember I showed you that right here? If you don't like that, you can use coalesce to fix that too. So here I'm saying, instead of saying sum of X, I'm saying coalesce sum of X, and if that's a null, return 0, and I get the mapping I want. Okay, so that's how you get around some of the weird problems you might have with the aggregates. So I think it's kind of useful. Mapping strings to null. This is the opposite. I wish they would have had something that sounds like coalesce, but it doesn't. Like there's coalesce and then there's null if. I don't know why they did that way, but that's what the SQL standard did. So this goes the opposite direction. This takes a string and converts it to a null. So here I'm saying F and G and NA, which is my special string, select X and null if. If this is a null, then give me that string. And again, an NA has become a null. This is the double. This is the null, turn to NA, and then null if, turn back into a null. So that's like your full circle there with the two of them. You would never write that, but you get the idea. Nulls in row expressions. This might be very Postgres specific, but effectively we have something called a row expression, which is sort of a combination of what's like a composite value, which contains multiple fields. So in Postgres, if you have, this is kind of weird. If you have a null and you compare it, you cast it to an integer array, and you ask if it's null, it's true. If you have a zero-length array and you cast it to an integer array and you ask if it's null, it's a false. That's good. But if you have a null in an integer array and you ask if it's null, it's false. So a null in a array is not a null, but a null itself as an array value is a null. Yeah, whatever. This gets really bizarre. If you ask if a empty row is a null, it is. If you put a null in the row, it's still null. But if you put two rows in the null, two rows in the row, it's null. But if you put a null and a non-null in there, then it isn't null. So two nulls is a null, but if you have a non-null in there, then it is. Yes, sir. Yeah. Right. Right. So the question is, what if there's nulls in every column? Would the row still be counted? I've never tested that. I don't think we would care. We would still behave the same way because the SQL standard is pretty clear on that. Yeah. Star is a special case. That's a great question. So when you're saying count star, if that expanded out to all the columns and all the columns were null, would we? Yeah, we can't do that because the standard pretty much says star, just count all the rows, and we can't. That would be, I would say that would make it even harder to understand, kind of. Yes, Richard. I don't think it is. I think it's an SQL standard thing. What's interesting is that the system's pretty smart. So if I say a null and a non-null, is that null? No, it isn't. But it also is not null. So again, with a multi-valued field, it's not null, but it also is not null, right? Yeah, right. So it's kind of interesting. Queries returning null in the target list is kind of interesting. So if we create a table and we do a select and there's nothing there, if you actually do a query that returns no rows, it actually returns a null as the value. Again, another case where we're generating it on the fly. In fact, I can even test it. And I can say, is the output of this null? And in fact, it will tell me that it is. It returns one row that's nothing in it. So this is my conclusion. this is Jeff Davis, who's one of our sort of back-end engineers. He has this great question. Oh, that makes sense. When you see individual behaviors of null, they look systematic, and your brain quickly sees a pattern and extrapolates what might happen in other situations. Often, that extrapolation is wrong because null semantics are a mix of behaviors. I think the best way to think about null is as a Frankenstein monster of several philosophies and systems stitched together by a series of special cases. And I think that sums up what I've shown you. I promise there'd be some perplexing sort of ideas here, and I think that really understands it. And again, it's a practical case of what behavior is the most reasonable for a particular query, and unfortunately, it is not always consistent with behaviors in other areas. So that's about it. There is a blog entry there at the bottom that actually is a sort of description of this presentation as a blog. It looks like something got cut off, but I think that's okay. So I actually have no time. I have no time left. So the good thing is we got a chance to ask questions. I could take one question within the next 30 seconds I have left. And we're good. Okay, well, thanks very much. Appreciate it, guys.
I don't know why I do if I can just want this stuff off.
Great. Yeah.
Nulls are bad in the databases that I manage.
Good morning.
Howdy.
I saw your post that you got into your suite.
Yeah, I just got it like half an hour ago.
Crazy flight now.
It was.
Singapore, Hong Kong, Heathrow here.
No, I left on Japan.
Yeah.
5:15.
I love everything that we all as well. I don't have to worry about counting anyway.
I got a weird question for you. Let you finish your type here.
I'm trying to find all those. Continue on with this.
Good to see you. I haven't seen you in a while. Yeah, I agree. Are you going to be around for the whole week? Good. I'm here till Monday. Excellent. I'll see you tonight, maybe, right? I will be here. All right, good. Excellent. Excellent. Should I use this aid?
Yep. That's
Can I
the one.
use it?
I don't know.
Yeah, you use that one.
Let's guess, what distro are you using these boxes? Because I just realized when I talk tomorrow, I got to do a live demo.
I'm just gonna have to stop this broadcast here, I guess.